mechanism for the exam, unless you want to. If you certainly want to, I won't stop you. But the idea was to show that it's an E2 reaction that we're going to see. Okay, so I just want to make sure, we don't want to memorize the particular mechanisms, but hopefully see some of the common features. Okay? So we'll call it a limitation, and I'm not sure if it's a limitation or a problem. So let's take our secondary alcohol again, and just isopropanol here, and let's react this with, a lot of times you'll see H2CrO4, sulfuric acid, and water. Or you might see CrO3. So we can treat those interchangeably right now. And there's other reagents as well. So what you're going to end up doing is you make a ketone. So we go from our secondary alcohol to a ketone. So that's great. The limitation or the challenge comes in, I'll go over the page break here, when using a primary alcohol. If you were to take a primary alcohol, let's just, like the line, I'm not sure how that happened. Let's erase that. Let's draw it like this. Put the OH up here. Let's put all the hydrogens in here. Actually, and now to help highlight, let's make this an R so it kind of stands out. So there's our primary alcohol. If we were to use the Jones reagent, and we'll just stick with this one, so I can write it, H2CrO4, sulfuric acid, water. You will first get your aldehyde that we have here. However, it's really hard to actually isolate this aldehyde. You generally cannot stop this reaction. What's going to end up happening is it's going to get oxidized again. Same reagents, right, over and over. So what you end up getting, I should say, is the carboxylic acid. So this is just how it works. And the reason for this we're actually going to cover in chapter 18. And I think we'll wait till then to get to that. So what we're going to say right now is that if you have a primary alcohol here and you treat it with this Jones reagent as an oxidizing reagent, you're not going to end up with the aldehyde, but you end up with the carboxylic acid. Okay, so it just over-oxidizes. And so that could be a potential limitation. So let's say instead you actually wanted to make an aldehyde. I have a primary alcohol. I don't know why, but for some reason I really want to turn that into an aldehyde. There is a way to do that. And there are other reagents. There are other oxidizing agents. There are all sorts of other oxidizing agents, but we will just cover these two, for example, for now. We won't go over the mechanism. These are actually versions. You're way ahead of me. Exactly, Crystal. PCC. So that's where we're going right now. So we need to use something else to actually oxidize the aldehyde. And there are two common reagents that are used. One of them, two common reagents that are variants of that Jones reagent, uses this species here, which is the conjugate acid of pyridine, or pyridinium, CrO3. Cl is a salt. This is known as pyridinium chlorochromate, which is also known as Corey's reagent, after E.J. Corey, a chemist at Harvard. Is this? Or saying pyridinium chlorochromate is not the simplest thing always to say, so just PCC for short. Or there's one other version. This one's kind of written in a strange way. CrO3. Start over a little bit neater. I don't think that's actually neater, but I guess we'll go with it. With pyridine here, there's two pyridines coordinated to it. And this is known as chromium oxide pyridine. Collins reagent, named after this fellow named Colin. This one doesn't have an acute abbreviation like PCC. So what we'll see later on when we start talking about aldehydes and ketones is that, there's a reason that this particular aldehyde here gets oxidized to the carboxylic acid. And it really has to do with two things. It goes to the strength of the oxidizing reagent here, so this chromic acid, and also water. We're going to see that if you have water in the presence of an aldehyde, most of it is actually what's known as the hydrate. Water is added to the aldehyde. So these other oxidizing agents actually give you some control because they're weaker, and you can eliminate water from the reaction. So I know that probably is a little abstract, so let's give an example here. Let's take, if we can go up a little bit. We'll just put the ring on there here so it's a little easier to see. Drawn in a kind of strange way, but this hopefully helps show this. So now let's take this alcohol and let's first treat this with the Jones reagent. So H2CrO4, sulfuric acid, and water. This is actually going to oxidize that primary alcohol all the way to the carboxylic acid. Okay, so we end up with the carboxylic acid. If instead we use that same alcohol, and now I'm just going to abbreviate it as PCC. I don't expect us to have to memorize those structures. Using the name PCC is fine. Our solvent now is dichloromethane, because something I didn't mention before, but this chromic acid is not soluble in dichloromethane, so we have to use something like water. But let's say we don't want water in the reaction. So the PCC actually solubilizes the chromium species, as it's now this pyridinium salt. So we can use a solvent like dichloromethane, keep the water out, and now we can actually stop at the aldehyde. So this is a really nice tool for oxidizing with a primary alcohol. The secondary alcohol, it doesn't matter which reagent you use because all you can do is go to the ketone. But with the primary alcohol, it does matter which reagent you use. You're either going to end up with a carboxylic acid or an aldehyde. The reason for bringing this up now is that we've made, let's say that aldehyde on the bottom one here, we could now carry out a Grignard reaction and form a carbon-carbon bond. So this is very useful in terms of synthesis. I'll scroll down a little bit. Why don't we just make up something here? Let's do the classic quiz question that I would ask. Let's use a ring just to again make it look a little bit easier. How about let's decorate it with an alcohol here? How about an alcohol over here? And about an alcohol down here. This is a bunch of random groups. Now, I'll ask you, let's take a minute, and what happens if you oxidize with the Jones reagent? It's not written in the middle of the arrow, but if that'll work. You have an excess of this reagent, so it's going to oxidize anything that it can, or PCC. So imagine you have multiple moles of this. So anything that can be oxidized will be oxidized. So let's pause for a minute, if you would, please, and predict the products of those two reactions. right, hopefully everyone's coming up with something here. So let's think about with the Jones reagent here. Our secondary alcohol, secondary, primary, tertiary. Secondary alcohol is just going to become a ketone. Primary alcohol is going to oxidize all the way up to the carboxylic acid. And this is where I'm a terrible person. I always put a tertiary alcohol here. Nothing is going to happen. We cannot oxidize that tertiary alcohol any further. Otherwise, we'd have 5 bonds on the carbon. TCC, put it down below here. Secondary alcohol, again, just goes to the ketone. It doesn't matter which reagent you use. The key is with the primary alcohol. That's going to oxidize to the aldehyde. Tertiary alcohol, again, nothing will happen to it with that carbon. Okay, so that's where we see a difference between these reagents, and by there I mean this primary alcohol. So with us, if you have a secondary alcohol that you want to oxidize to a ketone, you can use your favorite reagent. Jones reagent or PCC, it doesn't matter. In reality, a lot of times you might use this one. It's just easier to work with. Tertiary alcohol, you cannot oxidize any further. So primary alcohol, it does matter which reagent is used. Chromic acid or the Jones reagent to generate the carboxylic acid, PCC or the Collins one, if you like that one better, to generate the aldehyde. Okay, so then I forgot to mention at the very beginning of this, this goes back to chapter 11. Apologize, I meant to say this at the beginning. It's 11.4c, page, starts on page, I can't read my own handwriting. I think it says 348. Yes, and James asked, there's lots of other reagents one can use. There's the Collins reagent, there's what's known as the Des-Martin reagent, the Svern reagent. There's all sorts of other oxidizing agents that you can use. They all have their advantages and disadvantages. A disadvantage of PCC, it's easy to write on paper, but again, it's a chromium reagent. And so a lot of times we're trying to move away from these heavy metals. There's a great reagent, if you're really interested in it, it's known as the Des-Martin reagent, which actually uses hypervalent iodide. So it's an iodine in a high oxidation state that is a very useful oxidizing agent. Remember, too, I made that one time. It was actually quite fun. The precursor is explosive, so you need to be careful with it. The Svern, SW